Hello, today we'll have a lecture about Newton's second law. Uh, we can write that down, Newton's second law. And previous lecture we had Newton's first law. And Newton's first law was, or Galileo's principle of inertia was saying that when there is no force applied, there is no acceleration, so the body is at rest or moving with a constant speed in a straight line. So today we are going to talk about acceleration. So body moves with acceleration when force is applied. So this means that in order for body to move with acceleration, in order for the velocity to change, we need force. So we can write another similar sentence that body, maybe it will be easier for you to understand, body accelerates. It means that velocity increases, or decelerates. Decelerates means that velocity decreases. It accelerates or decelerates. It means that velocity changes in some way. Only when force is applied. Similar sentence, but the idea is expanded a bit. And it can be written in the form of F is equal ma. So force, when there is a force, there is acceleration. So and mass is defines the inertia. So it means in order to make the body move with acceleration, if it's a bigger body, it's having bigger mass, you need bigger force to apply. And if the force that you apply is much smaller, then for the same amount of mass that body has, you will produce lower acceleration. So when there is a force, there is acceleration. For bigger objects, if m increases, you need bigger force for the same acceleration. So in vector formulation, it would be F equal ma, where acceleration is also a vector. So the most common force to change the motion of an object change the velocity is gravitation. Gravitation force. As you know, Earth attracts all the objects having mass, so produces a force. So gravitational force this is the law, the equation. So it's given like F. This is gravitational force, capital G, m1 m2 divided by r squared. So if you have two masses, two bodies having mass, so it's m1 and this is m2. So the distance between them is r. So they are attracting each other with a force. So this is m2, so m2 is attracting m1, and m1 is attracting m2. So each two masses, they attract each other by the gravitational force. It's not only the Earth that attracts us and other objects, so that we don't go to space. It's all the mass attracting objects. Although, for example, two people sitting nearby each other, they attract each other with forces, but those forces are very small, so we can't feel them. But we feel gravity because Earth's mass is huge compared to our mass, and we attracted by the same forces. But so the force produced by a huge amount of mass is very big. So that's why we feel we attracted with the force with huge force that Earth attracts us, and also we attract there by the same force because Earth's mass is huge. So two masses are attracting each other with an equal force but opposite direction. F1 and F2 equal in magnitude but opposite direction. Equal in magnitude, let's write. Okay, so gravitation is gravitational force. It is non-contact force. So contact doesn't need it to be between masses. So they attract to the gravitational field. It's a form of matter that if this m2 is in m1's gravitational field, it will be attracted. So it's attractive force. So we can write that down, that it's non-contact force. Friction is contact force, for example. Attractive force. Depends on masses. Mass depends on mass and depends on distance. The bigger r, the lower the force. R squared is here. So we have here this equation. F is ma. So when gravitation performs motion, so this a is important, and this a becomes g, as we're referring to Earth's gravity. So we can write this equation also like in the form of when there is a motion performed by gravity, some object is falling down, so we can write like it is m. Let's write maybe on the other side, so keep it clean. So when there is F equal ma, so we can write that it is F is capital G, capital M, small m, and r squared. So this capital M refers to the mass of Earth. When Earth is acting on an object and pulling it down, so this is constant, this is constant, this is when something is happening close to Earth's surface, it can be held constant because the distance change doesn't affect that force that much because M is very, very big. So it can be written in the form of Gm. So this G would come from these three. Let's say these two are constant and this one is, let's say, pseudo constants. So it can be when close to the Earth's surface, it can be held as a constant. So from these three constant we get Gm. So if you remember, it used to be written as mg. So ma or mg, it is acceleration due to gravitation, due to gravitational force. And also when the force, gravitational force, is acting for, so G has the value 9.8 meters per second square. It can be written as it is approximately 10 meters per second square. So it means that every second, if object is falling down to Earth, every second Earth's gravity is attracting the object, so its speed increases every second. Its speed increases by 10 meters per second, so every second. So if it is falling for 3 seconds, so it means that its initial speed, let it be 0 meters per second initial, v initial speed, yes, initial velocity, in this case speed, because only for now matters only the magnitude. So it means that during first second its initial is 0 meters per second, then it increases to 10 meters after first second, yes, 10 meters per second. Then at second number 2 it increases to 20 meters per second, and it hits the ground with what? With 30 meters per second. So it means that it increases every second. So it would be 0 second, first second, 2 second, 3 seconds. First second, second second, third second. So it means that velocity increases because acceleration G is this, and G is constant here. Constant and is equal to this. Okay, so now what I wanted to tell you is a bit philosophical, maybe, is When we're speaking about gravitational force, and we're saying that gravity attracts some kind of object, Earth's gravity, it can be Earth, it can be moons, some kind of, in this case, let's say it's Earth's gravitational force attracting some kind of smaller object and it's falling down. So, and we are expressing it in the case of capital F is mg, with referring that is gravitational force. And this motion, that object is accelerating due to g. So this is called F gravity. F gravity. Gravitational, there is force between two masses. It can be written in this form. In this form, you see like this. Gravitational force is between two masses. They may not produce any movement because two masses, let's say two planets, are attracting each other and just they are holding each other in place. Or a book put on a table, it may not produce any movement. It just is attracted down and that's it. And it doesn't move. So these are gravitational forces. But when we speak about movement, we say we express this equation in mg, and we write that it is F gravity, that some kind of object is pulled by gravitational force, but we don't say gravitational, we just use gravity. This is the thing. And there's very slight difference if you if you say gravitation instead of gravity, it's the same because the force is the same. So just some kind of small difference that some people make in the books. So that's what I wanted, just small remark to tell you. Now free fall, there is a thing called free fall. Free fall, it means that objects are falling freely in gravitational field. It is due to gravitational force. And in this analysis, we neglect air resistance that brings the friction. So there is no other force except Earth's gravity in the simplified model. So as I told you, the speed of the object, it increases when the object falls down and approaches the Earth. So as we say, we can write it once more, that the object is falling down to the Earth. Gravity is attracting it. Gravitational force, F gravity is mg. G, it is 10 meters per second per second. And if the object, as I told you, is falling for 3 seconds, so V initial is 0. V initial is 0. So initially it is 0 meters per second. At first second it is 10 meters per second. At second number 2 it is 20 meters per second. At second number 3 it is 30 meters per second. So increases every second by 10 meters per second. So this is the movement with constant acceleration. So G is constant. So A is equal to G and it is constant. So what is happening to V in time? Vt is what? It will be V initial plus what? Plus GT. So this will be plus GT, or it can be written in more general form as AT, because when we don't not refer to gravitational field. So F units for gravity, maybe I forgot to mention you that if F is MA in general or mg, so the units of F, how can we find? So we can find by this, because units for mass are kilograms, units for acceleration are meters per second squared, so time meters per second squared. So these are the unit, kilogram time meter divided by second square, and it is this unit is called Newton, in honor to Isaac Newton. So what is very important here, it is that this this notion was free fall was investigated by Galileo, and he was throwing objects from the Tower of Pisa, and what he said, that what's very important, that every object falls with the same acceleration. So if it falls with the same acceleration, it means that they fall with the same speed. So what's very important from free fall is that every object falls down with the same acceleration, velocity, regardless of its mass, of object's mass. So this, although it's written here in the corner of the page, but it's very important notion that from free fall, every object is falling down with the same acceleration or velocity. So it means that if you have a let's say there is experiment on YouTube, Apollo, it's double P or double L, I forgot, but Apollo 1P, Apollo experiment, where they show on the moon, after they have landed on the moon, they show that heavy hammer, let's say very heavy, and feather, very light, they fall with the same, they are thrown from the same height, and they reach the ground at the same time. So it means they fall with the fall with the same velocity and acceleration. So because on the moon there is no, so it's regardless of their mass. So on the moon there is no atmosphere, so there is no friction. So friction, if friction is neglected, then you can see these things that Galileo said, that acceleration and velocity that doesn't depend on mass. Force depends, but not acceleration. So what I wanted to tell you is that if we have what is weight? What is weight? And weight is, we will talk maybe a bit later what is, how it's when we will talk about forces, but weight, it is understood if you have, let's say, table, and you put the box on the table, so F equals mg, and the gravity, this is blue, is F gravity, so it's F gravity, so it pulls down, so gravity acts on the object, on the box. But what is weight? Weight is the force that this box, due to gravity, puts on the table, because the table has to hold it. So if there is some kind of object that is holding something, so it will experience the weight. So this is F weight. So F gravity and F weight are the same in magnitude and the direction, but they act on different objects. Box is pulled down by Earth's gravitation, so it acts on box. So it acts on box. Gravity acts on box. Weight, box, due to gravity, exerts this force on table. So on table, so gravity is the force on the box due to Earth, but this box exerts a force on the table. So if you see that red is beginning at the table surface, this blue is in the middle of the box. So we will discuss this a bit more in when we talk about forces. Now what's happening? We were dealing with free fall here. Free fall, so when you are throwing, let's say, from a balcony some kind of object down, but what happens if you are throwing the ball up? When you are throwing the ball up, let's say a human is standing there, let's draw a primitive human being, and it throws the ball up. So that ball goes up. So you throw it with v initial, some kind of v initial, let's say 30 meters per second, v initial. And when you throw it up, what happens to this ball? So it happens that this ball is decelerating. So it means that this ball, you throw it with 30 meters per second. What is happening? It is happening that this ball is increasing, but it is Earth's gravity, 10 meters per second square, it is decreasing the ball. So after it is 0 second, this is 1 second, so it will be 20 meters per second. 2 seconds, so it will be 10 meters per second. 3 seconds, it will be 0 meters per second. Here the ball is not moving anymore, 0 meters per second. So the ball was increasing, going up. Now the ball is going down from 0 meters per second. It's increasing to 10 meters per second, to 20 meters per second, and it hits and it reaches the ground. The same, let's say that you would have thrown from the ground, so you were very close to the ground. So it hits the ground or hits you, comes back to your hand. Let's say you throw from your hand and catch again from your hand, so it comes back at 30 meters per second. The same the initial you throw, you catch it back with 30 meters per second. So in this case, gravity decelerates. So decelerates. Here the gravity accelerates the ball. Now what is a bit difficult, that is, or not as difficult but as annoying, are kinematic equations. So kinematic equations like we had in